Hello everyone, I am Himadri Dey, a professional teacher in the field of chemistry since 27 years. In my YouTube page, I will try to make you understand the detailed explanations, suggestions for your term 2 board exam, which covers CBSE, ISC as well as WBB board. Please remain till the end. I think I can able to make you understand the topics. Thank you. Hello everyone. So today's topic is basicity of amines. Okay. Please remain till at the end. I will make you understand. Okay. So basicity of amines. Now listen the first point. A base reacts with an acid to form salt and sometimes salt and to form salt and water. So a base reacts with an acid to form salt and sometimes salt and water. Our consideration is only the basicity of amines. If we consider amines, nitrogen has lone pair of electron. You know that nitrogen has atomic number 7, electronic configuration 2, 5. So there are 5 electrons in the valence shell of nitrogen. Out of the 5 electrons, nitrogen makes bonding by giving 3 electrons, 1 and 2, 3, and 2 remains. This is the lone pair of electrons. This is a lone pair of electron, okay? Acid. You know that acids are the substances which in aqueous solution releases H positive ion called proton. It comes from an acid. So this is the base, amines, acid releases proton. What happens? The proton of the acid gets attached to the lone pair of electron on nitrogen atom. So you get the salt. Remember it, in organic chemistry, any positive ion while it gets attached, the central part becomes positive. This is anilinium ion. Actually this is called anilinium ion. Addition of proton is called protonation. So whenever you consider the basicity of amines, remember 2 main factors. One is availability of lone pair of electrons on nitrogen atom. Another is protonation. The availability of lone pair of electrons on nitrogen atom depends on 2 factors. One is presence of electron donating groups, another presence of electron withdrawing group. And the protonation depends on steric hindrance or bulky group effect. If any amine contains bulky alkyl or aryl groups, then proton finds less space to attach on the lone pair of nitrogen. That's why protonation becomes difficult and basicity decreases. Let's see the details. Okay. Now listen. the basicity of amines depends on the density of lone pair of electrons. Greater the density of lone pair of electrons, though we represent dot, it's not a dot, it's a cloud-like representation, remember it. Greater the density of lone pair of electron on nitrogen atom, the protonation becomes easier and basicity increases. So, presence of, write down, okay, presence of electron donating groups. This is also called positive inductive effect. Class 11 you will find, okay, detailed inductive effect. That is class I effect. So presence of electron donating groups. If electron donating group is present in amine, then nitrogen has already lone pair of electron. The electron donating groups donate lone pair of electron to its by inductive effect, class I effect. That's why this is the volume of lone pair of electron on nitrogen. If there is any electron donating group, it also donates lone pair of electrons. So the density of lone pair of electrons becomes more. That's why the protonation becomes easier. So basicity increases. And what are the examples of electron donating group? Remember it, the electron donating groups are I will discuss only those groups which are very useful in this chapter, okay, are alkoxy groups, such as, this is denoted by OR, such as methoxy, ethoxy, OCH3, OC2H5, greater electron donating power than alkyl groups. Any alkyl groups are, say, ethyl, these are the bonds, not negative, okay, methyl, etc. Greater electron donating power than hydrogen. So, once again, remember it, the alkoxy groups have greater electron donating power than any alkyl groups, and the alkyl groups have greater donating power than hydrogen. If we say, sir, which one has more electron donating power? Ethyl. If you say which one has more electron donating power, obviously ethoxy. Now, so remember it, the basicity of amine depends on the density of lone pair of electron on nitrogen atom as well as protonation. Greater the density of lone pair of electron on nitrogen atom, more will be the basicity. If electron donating group is present or is attached with an amino group, then the density of lone pair of electron increases. So the protonation becomes easier because the hydrogen positive ion released by an acid easily gets attached with the nitrogen atom, resulting more basic. And in reverse sense, if we consider the reverse sense, okay, if we consider the reverse, that is presence of electron withdrawing group. If electron withdrawing group is present, if electron withdrawing group, electron withdrawing group is present, okay, if electron withdrawing group, that is minus I group, negative inductive effect, then the density of lone pair of electron on nitrogen decreases. See, if we consider benzene is attached to amino group, can you say its name? It's aniline. You know that benzene attracts electron by resonance. Okay, later on I will discuss resonance. Benzene attracts electron by resonance. So the density of lone pair of electrons, say this is the cloud of nitrogen. If benzene is present, you see the cloud becomes lighter. The clouds becomes lighter. So the basicity decreases. Remember it, if the nitrogen atom of amino group is directly attached to benzene, then that's called aromatic primary amine, and there is no benzene, this is called aliphatic primary amine. Aromatic, aliphatic. Can you say which one is more basic, aromatic or aliphatic? Yes, correct. Aliphatic, because they have electron donating group, so the lone pair of electron decreases. In aromatic amines, benzene has electron withdrawing nature, so the density of lone pair of nitrogen decreases, so basicity also decreases. I will discuss. Okay, what are the examples of electron withdrawing groups or minus I groups? Now listen, now I will discuss, here I am discussing only that groups or atoms which are necessary in this chapter, okay, not another. Now nitro group has stronger electron withdrawing power than cyano group. Cyano group has stronger electron withdrawing power than benzene ring, C6H5, or C6H5 is called phenyl or aryl group, and stronger than hydrogen. There are another electron withdrawing groups, another electron donating groups. Later on I will discuss in inductive effect. Inductive effect is not considered here. Here is only my main discussion on basicity of amines. Okay, so please write it. Now the next. Now another factor which depends on basicity of amines, okay, that is steric hindrance, because you know that a proton try to get attached on the lone pair of nitrogen atom. Say there are bulky groups are there. Say bulky groups are there. Say there are bulky groups. Okay. Say bulky groups are there. Now, if bulky groups are there, bulky alkyl or aryl groups are there, then the proton cannot come from this side. Proton, this is nitrogen, at the center nitrogen. This side, these are blocked. So proton can find only these sides to get attached on the nitrogen. But don't think that in liquid state, that in aqueous solution, the bases remain still. They also rotate. So proton finds very difficult to get attached on nitrogen if there are bulky groups. This is called steric hindrance, and that's why if there are bulky groups, the protonation becomes difficult and basicity decreases. So remember it, presence of bulky large alkyl or aryl groups groups hinder the proton to attach on the nitrogen atom of amines. That's why protonation becomes difficult. So basicity decreases. This property is called, this is known as steric hindrance. So before going to question and answer discussion, remember it clearly. The extent of basicity of amines depends on the density of lone pair of electron on nitrogen atom. Greater the density of lone pair of electron on nitrogen atom, more will be the basicity. Presence of electron donating groups such as alkoxy groups, methoxy, ethoxy, such as alkyl groups, ethyl, methyl, propyl, increases the density of lone pair of electron on nitrogen atom. So protonation becomes easier and basicity increases. If there is any electron withdrawing groups, benzene ring, nitro group, cyano group, can you tell me halogens? I have forgotten to write. Halogens also have electron withdrawing natures. Good. So presence of electron withdrawing groups decreases the density of lone pair of electron on nitrogen atoms, resulting decrease in basicity. Another factor, that's called steric hindrance. If any amine contains bulky alkyl or aryl groups, remember it, steric hindrance is mainly necessary for secondary and tertiary amines, not primary, in amines. So if there is any bulky alkyl or aryl group, aryl means benzene, then the proton finds less path to get attached on the nitrogen atom and basicity decreases. This phenomena is called steric hindrance. So try to understand some very important exam questions and answer on the basicity of amines, which are very helpful for your coming board exam. Okay, so the first question, I think you can understand it. Okay, if you can't understand anything, please write to my description box. One thing is that till your final board exam, I will post a number of YouTube pages. Please subscribe my channel. It will helpful truly. Now, first question. Which is more basic? Aliphatic or aromatic? Primary amine, that is 1 degree amine. This is a question. Give reason. So this type of question carries 2 marks or 1 mark. Don't write more, okay? Write the main points. First, it's the answer sheet. Aliphatic amine are denoted by R NH2. Mainly it is aliphatic or aromatic primary amine, NH2. This is aliphatic. Aliphatic 1 degree amine. This is aromatic. You can write Ar NH2 aryl. When benzene is attached to anything, its formula is C6H5. It's called aryl or phenyl. Aryl or phenyl. Or it may be denoted as PH NH2, or it may be written in this way. Okay, all are correct. Okay, so this is an example of aromatic primary amine. These are denoted aromatic. Benzene, actually benzene, if you consider benzene only, it has formula C6H6. When benzene is attached to nitrogen of NH2 group, they may be called aryl or phenyl. Ar for aryl, phenyl, same thing. So can you tell me which is more basic? Listen now. Any alkyl group, this is alkyl group, okay? In aliphatic primary amine, R is denoted by alkyl group. Methyl, ethyl, propyl, butyl, etc. You know that alkyl group has electron donating nature. I have already given. While the benzene ring, phenyl or aryl group, they have electron withdrawing nature. They have electron withdrawing group. And you know that if electron donating group is present in amine, the density of lone pair of electron increases. The density of lone pair of electron increases, resulting more basic. Presence of electron withdrawing group. Okay. Now say this is the density of lone pair of electron previously. If electron withdrawing group is present, then the density of lone pair of electron decreases. Density of lone pair of electron decreases, so basicity decreases. So always remember it. Aliphatic primary amine is more basic than aromatic primary amine. So the answer is, I will write in here, okay. So the continued answer is aliphatic 1 degree amine is more basic than aromatic 1 degree amine. Primary amine is denoted by 1 degree. Understand? So the next question, okay. So the next question. Now one thing, remember it. Steric hindrance is applicable in only aqueous solution. When in amines, if any question is there from basicity, if nothing is mentioned, remember it, it is in aqueous solution. They will not mention in any question in aqueous. Sometimes they mention. And remember, steric hindrance is applicable only in case of aqueous solution. In gaseous state, steric hindrance is not considered. Only the electron donating or withdrawing, that's inductive effect, is considered. So the second answer, answer 2. So the question, second question, compare the basicity of amines. Give reason. That is decreasing order. It is mentioned. They will mention either arrange the compounds in decreasing order of basicity or in increasing order. Okay. So CH3 NH2 CH3 N CH3 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 H3 NHCH3 and NH3. This is methylamine. Always remember the name, okay? This is methylamine. Methylamine. Can you tell me whether it is primary, secondary or tertiary? Good. It's a primary amine. It is trimethylamine. Trimethylamine. It's a 3-degree amine, tertiary amine. It's a trimethylamine. It's a 2-degree amine acid ammonia. Now, you know that in whether it is primary, secondary, tertiary or ammonia, every one contains lone pair of electrons on nitrogen atom. Every one contains lone pair. The pair of electrons which do not take part in chemical bonding are called lone pair of electrons. So all are basic in nature. All are basic. Now, can you tell me which is more basic, most basic? This, because there are 3 electron donating methyl group. You know that methyl group, any alkyl group has electron donating nature, okay? In answer, write this way. So obviously, trimethylamine is more basic, isn't it? No, wrong. Trimethylamine is not the most basic. Remember it, trimethylamine is not the most basic, because you know that in basicity of amines, 2 major factors are to be considered. One is density of lone pair of electron on nitrogen and another is steric hindrance. So if we consider it, remember it, secondary amine is the most basic. And which one is least basic? Ammonia, there is no electron donating groups. So it is the least basic. Now, so remember dimethylamine is more basic than both of them. And if we consider the 2, methylamine is more basic than trimethylamine. Methylamine is more basic than trimethylamine. Dimethylamine is more basic than methylamine. Methylamine is more basic than trimethylamine. Why trimethylamine is less basic than methylamine? Due to steric hindrance, that is bulky group effect, protonation becomes difficult here. Actually, I have already told you in basicity of amines, 2 main factors are to be considered. One is density of lone pair of electrons and another is steric hindrance. And here steric hindrance predominates. That's why it is less basic than methylamine. And ammonia is least basic. So remember this, okay? This is a very important exam question. Now the third question. Compare the basicity of amines with reason decreasing order of basicity. Decreasing order of basicity. It is less basic than 2 degree and 1 degree due to steric hindrance. Due to steric hindrance, okay, for which protonation becomes difficult. Though there are 3 electron donating group, but here steric hindrance predominates over inductive effect. Here steric hindrance bulky group effect predominates over the electron donating inductive effect of 3CH3, that is methyl groups. Write it, okay? So if there are ethyl groups, but remember it, the question as nothing is mentioned, so remember it, the amine should be discussed considering in aqueous solution. If nothing is mentioned, it's aqueous solution. Now another question, question number 3. If we see, give ethyl amine, diethyl amine, triethyl amine, ammonia. Remember it, nitrogen has lone pair of electron. Every time nitrogen has lone pair of electron, okay? Then can you tell me which one is most basic? Which one is most basic? So the decreasing order of basicity. The decreasing order of basicity, actually the question is arrange the following in decreasing order of basicity. Okay, directly I will write the answer. Arrange the following in decreasing order of basicity. Same question, same format. Which one is most basic? You see, sir, there are 3 electron donating alkyl groups. It has only 1, it has 2. So this is the most basic. Correct? No. This is not the most basic. Again here, dimethyl amine. Again here, diethyl amine. Diethyl amine is the most basic. Then, now consider the 2. Can you tell me which is most basic? You see, sir, see, ethyl, if there is methyl group, trimethyl amine is less basic than methyl amine. Similar thing happen where? No. Here exceptional. Here trimethyl amine. Here triethyl amine is more basic than ethyl amine. More basic than ammonia. So remember it, the change factor is here and here the change only. Whether it is methyl or ethyl, secondary amine is always more basic than primary or tertiary amine. If methyl group is there, primary amine, 1 degree amine is more basic than 3 degree amine. If ethyl group is there, 3 degree amine is more basic. 3 degree amine is more basic than primary amine. Can you tell me what is the reason behind it? Listen now, 2 factors. One is inductive effect. Here it is plus I effect. Electron donating effect of ethyl group, another is steric hindrance. Though ethyl group has more volume than methyl. Still, here in this case, electron donating inductive effect of 3-ethyl group predominates over steric hindrance. It is more basic than ethylamine because in this case, electron donating effect of 3C2H5 groups predominates over the steric hindrance. That's why triethylamine is more basic than ethylamine. This is chemistry, okay? Lots of exceptional cases are there. Now, listen in these two cases, how to remember it, okay? What is the technique to remember it? Remember, in organic chemistry, mainly technique. Just follow the technique. You will never forget it. Just follow the technique. So, listen now. Notes, very important notes for you, okay? This is very important question. If methyl group, that is CH3, this is not negative charge, this is the bond. If methyl group is present, okay, if methyl group is present, then the decreasing order of basicity, write it, okay? Then the decreasing order of basicity 2 degree amine greater than 1 degree amine greater than 3 degree amine greater than ammonia. If ethyl group is there, if ethyl group is there, the decreasing order of basicity is is 2 degree amine, whether it is methyl or ethyl, 2 degree amine is more basic, but here the changes are there. 3 degree amine is more basic than 1 degree amine and it is more basic than ammonia. The change is here. Why tertiary amine is less basic than primary amine? In tertiary amine, when methyl group is there, due to here steric hindrance predominates over the electron donating nature of 3-methyl group. But here electron donating effect predominates than steric hindrance. This is the exceptional case. And in both the question are applicable in aqueous solution. I repeat, if nothing is mentioned, consider the basicity of amine in aqueous solution. So remember it, these are in aqueous solution. Matlab aqueous solution means in dilute solution, diluted with water. But if gaseous state is mentioned, now, okay, I will erase it. If gaseous state is mentioned, okay, no steric hindrance is considered. Write the notes. In gaseous state, no steric hindrance. Steric hindrance or bulky group effect is not considered. So in gaseous state, the decreasing order of basicity always 3° amine greater than 2° amine greater than 1° amine greater than ammonia. So remember it, whether it is ethyl, methyl, propyl, anything else, when propyl or ethyl or methyl or any alkyl group or any alkyl or aryl group is present, then always tertiary amine is more basic than this. No steric only electron donating orbital groups considered. Okay, electron donating effect is considered. Now the next last, okay, last question. Tell me which is more basic. Arrange in decreasing, they will give either increasing or decreasing, no matter. If decreasing order, highest to least. If increasing order, least to highest. Decreasing order of basicity. Can you tell me what is its name? Aniline. This is ortho position, meta position, para position. Say if we insert one NO2 group at para positions, that's called para nitroaniline. This is a common name, okay? Or if you say, sir, what is its IPC name? 1, 2, 3, 4 nitroaniline. Para nitroaniline. And here, say CH3 group is there, para methyl aniline. It's also called para toluaniline. So no substituent is there. Para position contains nitro group, para position contains methyl group. Nitro group has electron withdrawing nature, so it is electron withdrawing group. Methyl group has electron donating natures, so it is electron donating group. And you know that presence of electron donating groups increases the basicity of amine, whether it is aliphatic or aromatic. So if you consider 1, consider 2, consider 3, so obviously touch 3, that is para-methyl aniline, is the most basic, and then between the two it has neither electron donating nor withdrawing, but it has electron withdrawing, so it is the less basic. So it is least basic. So 1, 3, 2. This is the answer. Okay. Explanation on the basis of electron donating or withdrawing. Okay. Hope you understand the topics. In my next class, I will discuss another topics on basicity of amines.